Why do some chemical reactions happen instantly, while others take time or need a push? The answer is hidden in this curve. In this video, you'll learn how to read energy diagrams and understand what the transition state tells us about reaction speed. As the reaction begins, reactants climb up in energy. Imagine molecules getting stretched, twisted, and distorted as they approach the top. At the very top is the transition state, the highest energy point. It's extremely unstable and molecules can either move forward or revert back. Here, bonds are halfway broken and halfway formed. It's the tipping point, what the chemists call the point of no return. Some reactions end lower than they started. These release energy. Others end higher. These absorb energy. But both pass through a transition state. The height of the energy barrier from reactants to transition state is called activation energy. The higher it is, the slower the reaction, unless we helped it. A catalyst lowers that energy barrier. It provides an easier pathway, but doesn't change where the reaction starts or ends. You've probably added energy yourself by striking a match or cracking a glow stick. That energy helps the molecules reach the transition state. In biology, enzymes do the same thing. They lower the activation energy so that life-sustaining reactions can happen quickly, even at body temperature. Let's compare. Which reaction do you think is faster? The one with the taller hill or the shorter one? Pause and think. On all energy diagrams, energy is on the vertical axis, and the reaction progress, or reaction coordinate, is on the horizontal axis. Putting it all together, the diagram shows where we start, where we peak, and where we end up. This tells us both how fast and how favorable a reaction is. To recap, the transition state is the top of the hill. Activation energy is the height of the hill. Catalysts lower that hill, and energy diagrams help us visualize the entire path. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.